Hi again, it's me, Franklin, again, and here I am again in my office. I'm going to record one last video here today about using pipes. And the example that I want to work through here is kind of like the sad path of going through using pipes. The pipes video that I've previously published is one that gives us a pretty good idea of the happy path. So like this is what I should expect to have as input and output and how I should expect pipes to behave. But the problem with pipes is that they can be a little bit finicky sometimes, and they can be difficult to try to debug what's happening with pipes, kind of because in a lot of cases, the programs that you're using with pipes are not your own code. So you can't actually see anything that's going on in the program that's supposed to be reading or writing to or from the pipe that you're working with. And so I want to step through an example here that is taking us through using pipes in such a way that it will demonstrate a behavior that I kind of expect that you're going to see when you're starting to work with your assignment. I'm definitely going to go through this example again in class on Monday, but similar to the pipes video itself, I want to give you a good example of this so that you have an idea of how you can do the debugging if you want to do the debugging if you get to that point when you're working with your own implementation of a shell. So let's take a look at some code. The code that I've got here is also in the interprocess comms Git repository that I put up on the course webpage. And the code that's here is pretty short, and so it's short enough for us to take a quick step through in terms of what this code is supposed to do. This code will pipe, so we're going to create two new file descriptors in our open file table that represent the read end and the write end of a pipe. As with before, we're doing this before we're calling fork, because we want to have both of the processes that result from this fork call have a copy of the read end and the write end of those of that pipe. This is what allows them to communicate with each other. In the child process, I'm printing out this message that I'm waiting for a message from my parent, and I'm going to read from the read end of my pipe here. Anything that I read from the parent process on the read end of my pipe, I'm going to put to standard output. And then after I'm done reading, I will exit. In my parent process, I'm going to write this message to standard output, about to write to the child. Then I'm going to write to the right end of the pipe. I'm writing a very short message here. It's 3 bytes long. And then I'm going to print this message to my own standard output that I've finished sending this message to the child process. And then I'm going to wait for the child process to exit. So all this really does is take 3 bytes from the parent and send it to the child through this pipe. I'm going to make this code and I'm going to run it. And the expectation that I have is that we get high printed out and then both processes exit. But unfortunately, that's not the case here. Unfortunately, what we see is apparently something that's just kind of stuck. And this is the kind of behavior that you might be seeing once you get to the point of working with pipes in your own code. I want to take the time to step through this to see how we can try to debug this, even though in this case we can actually see all of our source code. Again, I want to debug this from the perspective of maybe I can't see everything because we're working with another program like CAT or TR. So what's happening in this case is that we've got about to write to child being printed out in the parent process. That's this first part. We can get a sense that write has apparently finished because message sent waiting for child to end has printed out here. So these two print statements are showing us that at least this line has maybe finished, and it's probably blocked here. It's probably stuck waiting here. The child process appears to have entered the conditional statement because we can see that this message has been printed out, but there's no further output here. So the read doesn't seem to do anything and the put char doesn't seem to do anything. I can take a look at PS here and I can see that I've got 2 frozen pipes. So both of my processes are there. They both launched, but they're both stuck. They're both blocked. They're both in this sleeping state. They're both waiting. I'm going to start this debugging session by kind of theorizing wildly about what has gone wrong. My theory at first is that the write call happened before the read was ready to accept anything. I want to preface this by saying that I am wrong. I'm very, very wrong, but this is my wild theory right now. And my wild theory tells me that I want to do some basic synchronization. So my basic synchronization is going to be that I'm going to use signals to have my child process indicate to the parent that it's ready to read something from the pipe. Again, this is the wrong path, but it's a good example of using signals again. So I'm going to go up to the top here, and I've already started setting this up. So I've got this flag, I've got a function that's called increment flag, and what I'm going to do is just after my pipe call, I'm going to say signal, sig user1, and I want to say increment flag. My parent process is now going to, just before saying write, I'm going to say printf, waiting for child process to be ready. And I'm going to say while flag is equal to 0, just spin, just don't do anything. So block. Block until the flag is set. My goal with this is that I want my child process to send a signal to the parent to say, yes, I am ready. And only at that point should you start to call write on the right end of this pipe. So I'm going to say printf waiting for a message from the parent, and then I'm going to send a signal. Kill, get ppid, sig user1. I don't think that's the right order. That should be the right order, but I'm going to check because I can't remember. PID and then the signal. Yes. Okay. So I'm going to send sig user1 to my parent to say, yes, I am ready for you to send the message to me. I'm going to write that. I'm going to control C. I'm going to terminate these two frozen pipes that I've got running right now. I'm going to make this and I'm going to run it again. And it's still stuck. It at least looks like it's doing things in the order that I want. So I'm waiting for the child process to be ready. That's from the parent process. Waiting for a message from parent. That's this line from our child process. Then about to write to child. That's this part right here in my parent process. And again, it apparently succeeds with write because we say message sent, waiting for child to end, but the child never seems to end. I'm going to hit Control C on my keyboard one more time here. When we're in this state, we often can't actually see what's going on with the code that we're working with because we're working with other programs in our child process. We're calling exec and they're calling read on the read end of a pipe. I'm going to say that we're going to use a program here called strace to help us with this. Showed this program before, but we're going to use strace with a couple of options to help limit the kinds of output that we're seeing with this. I really strongly advise you to take a look at the manual page for strace because it's going to show you all the stuff that I'm doing here. But for the sake of this discussion, I'm going to just tell you what I'm doing here. The first thing I'm going to do is I'm going to follow forks. I want strace to print the output of the system calls that are being made by all processes that have been launched by this process itself. So when I call fork, I want to see the system calls that are being made by the parent process, and I want to see the system calls that are being made by the child process. The other thing that I want to do is I want to filter some of the output. The first time that we ran strace, there was like this big glom of output that was kind of baffling, honestly, in terms of its volume. So I really only want to see things that are interacting with file descriptors. We're working with pipes. Pipes are using file descriptors. So I want to make sure that I'm just taking a look at those things. So I'm going to use -e on strace. -e allows us to filter the output. I'm going to say trace equals. And I'm actually going to ask it to trace three things. Things that use file descriptors, so %desc. Things that operate with files as arguments, so file, %file, and I also want it to do things that deal with processes, so %process here. So I'm going to zoom in here just quickly so that we can see this all in one line. So follow fork says I want you to follow all the pipes that have been called by frozen pipes. And then I want you to limit output of system calls to be those that deal with file descriptors, those that take files as arguments, and those file names as arguments, and those that are dealing with processes. I'm going to hit enter here, and what we're going to see is still lots of stuff, but what we can see is I'm calling clone pipe 2, which is cool. I can actually see not just that I'm calling pipe 2, but I can also see these are the numbers that I get back from the file descriptors. So file descriptor, the read end of my pipe is number 3, and the write end of my pipe is number 4 here. That's pretty cool. The next thing that we can see is that there's a clone call here, which is not fork. It is not fork. Clone is actually what's going to be invoked underneath the fork call that we're making. That's a discussion for later, but we can say here that this is where the fork is happening. So I can also see that because now I have 2 different process IDs that are printing these outputs. So the parent process calls write, waiting for child process to be ready. The child process calls write, waiting for message from parent. The child process sends the kill system call. So it is sending this to the parent process ID, and it's sending SIGUSER1. The parent process takes over, and this is that whole part where we're doing like add a stack frame and invoke the code in the function that the signal handler has registered, and then eventually return control back to wherever you were before. So we were in the parent process here, stuck in that infinite loop waiting for flag to be ready. And now we are invoking our signal handler. It is setting that flag. In my parent, I am in the child process, I'm getting back to the child process. And then here in the child process, I am calling read on number 3. That's the read end of my pipe here. And I am blocked. So what this says is that I am not going to be able to get any input until something has been written to me. So now I can confirm for sure that read is being called before the write is being called to the right end of the pipe. The write now here is coming from my parent process because we just finished handling our signal and we're saying about to write to the child. Write is being invoked here by the parent process. I'm writing to file descriptor number 4. That's the right end of my pipe, and I'm writing these 3 bytes. Hi. And this now says I have written 3 bytes. So the write succeeds. In the child process now, read resumes. So read blocks here, and now read is able to continue here with the H. Okay, so now it says read has returned 1 byte. It read an H. The parent process says, writing to standard output, message has been sent waiting for the child, and the child process calls read. It is unfinished, so it's blocked. The write is resumed, so this is us printing out, waiting for the child to end. The read is resumed. This is the I. Read here in the child process returns that 1 byte was read, but nothing has been printed yet. This is a little confusing. Then we have wait for. This is unfinished. And so what this is saying is that our parent process is currently blocked on wait. It's waiting for the child process to end. Our child process here is reading again, apparently successfully. It's able to read that 1 byte, and now it's stuck. So this is the part where it's actually stuck on the read end of our pipe. I'm going to hit Control C here. And what I'm going to do is I'm going to replace putchar with write. Putchar prints out 1 byte. It is equivalent to write to standard output. And okay, this changes things a little bit. So I have called read and I have called write to standard output. Putchar buffers its output. Putchar will buffer its output until there's a new line that's been printed out. So when we saw all of this read and read and read in the child process, and it was H and I and exclamation point, and it apparently succeeded, each time we called putchar, it wasn't actually calling write immediately to put our data to the child to the standard output. So the problem that we have here is still, though, that if I do frozen pipes with strace here, now we can see HI exclamation point. The read end of the pipe is blocked, and we're blocked on wait in the parent process. The problem that we're encountering right now is that read is blocked because we're trying to read from the read end of a pipe, and the right end of the pipe is still open. The way that pipes work is that if there's anyone who can possibly write to the right end of the pipe, holding the right end open, then read will block because somebody somewhere might eventually write to that end of the pipe. When we call pipe, there's one copy of the read end open and there's one copy of the write end open as file descriptors in the process control blocks open file table. One process that currently holds the right end of the pipe open is the parent process. The parent process holds the right end open. Parent process holds the right end open, and it holds the read end open. And so I'm going to close the read end, FD's at 0, close the read end. The parent never reads from the pipe. And I'm also going to change this here. I'm going to say close FD's at 1. Close the right end. Indicate to anyone reading this pipe that there's no more data left to be read. Okay, so in my parent process now, I've closed the read end and I've closed the write end of the pipe. I'm going to make this code, I'm going to run it. We're still stuck. Let's think about this one last time. Before we called fork, I asked for 2 new file descriptors to be created in my open file table. When I call fork, I'm duplicating my open file table. I'm duplicating my process control block. And so what's actually happening here is that the child process is trying to read from the read end of a pipe that it itself holds the right end open to. I'm going to add close the right end, and in the child, we're never going to write to this pipe. Close FD's at 1. I'm going to control C this, I'm going to make it, and I'm going to run this confidently without strace here. The issue that we had was that the read system call on the read end of a pipe will block if there are any write ends open. When I call pipe here, I'm adding 2 file descriptors to my open file table in the current process's process control block. When I call fork, I'm duplicating that. So now the parent process has an open end, a read end, and a write end open to the pipe, and the child process has a read end and a write end open on the pipe. The child process has to close the right end to the pipe because it will block on read if there are any writers on the right end of the pipe. The parent process has to close the right end of the pipe down here to say, I'm done writing to this. There's nothing left that I'm going to send to you, so anyone reading should terminate. Once all right ends of this pipe are closed, this read will be allowed to unblock. So what we've seen here is that it actually doesn't matter And I'm going to uncomment this line, and I'm going to make this, and I'm going to run it one more time here. Calling write before we've called read here is okay. It's actually okay. The important part is that read blocks if the right end to this pipe is open, if any right ends to the pipe are open. When we call fork, there are two right ends open to the pipe, one in the parent process and one in the child process. We have to close both ends of that pipe, one in the child process and one in the parent process after we're done. Again, I'm going to step through this in class. I'm going to step through this in class because this is a problem that you will encounter, but being able to use strace will at least give you a sense of what's getting blocked. So which file descriptors are getting blocked on and which system calls are getting blocked on.